Hey everyone, this is Slice of Life Coding by Jamie Dawson Codes, and in this video we're going to be going over LeetCode question 217 contains duplicate. Now, this is a unique question because yes, it is an easy question, but there's a lot of different ways to solve this problem, and I'm going to show you multiple ways to solve it because this could be one of those questions where you can really practice experimenting with different solutions that might have different time and space complexities and debating which one would make the most sense for passing an interview. Now, before we go ahead and actually jump into any code, let's make sure we understand the problem it's asking. So the question reads, given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So what that means is, in this example here, we see we have two ones, so those are the same, so that means we would return it true. But in this example, every single number is unique, so in that case, we would return false. So now that we know what we're looking for, let's start with solution number one. So the solution number one that I would do is basically a loop in a loop. So what you'd basically do is you'd have a left pointer and a right pointer. So the left pointer starts here, and the right pointer will start one to the right of left. And so the left pointer will stay still while the right pointer scans the entire array. And then you see, okay, I couldn't find any similar numbers, so I'm going to move left one to the right, and then I'm going to start right one right to the left, and then I'm going to scan the array again. Could not find any similar numbers, so we move left again, and we were able to see, now with here, we can see that it was able to find a duplicate. So that will work, but that has a time complexity of a big O of n squared, which honestly, not the worst, but not that great. Though it does have a really great space complexity of O of 1, because we're not making any extra space. We're just creating two pointers and moving them across the array. So the second solution is just to sort the array and then deal with that sorted array. So what we do is that we'd use something like dot sort, which is something that's built into JavaScript, which could take this array and then sort it from smallest to largest, just like this. And then from there, we're going to scan the array with two pointers, and then we're going to compare those pointers to see if we find similar values. So in this example, we have these two pointers, and they're just going to be moving down the array side by side. And here we'll see that we found 2, 1, so in that case, we would return true. Now here we have a time complexity of O of n log n, which is a little bit better than the time complexity for solution number one, but I think we can do better. That said, our space complexity is still pretty good. We're not creating any extra space. We're just creating pointers to move through the array. So our space complexity is still O of 1. And so the last solution that I have, which is the one that I'm going to be using, is basically just to use what's known as a set. Now, what is a set? So a set is a built-in JavaScript collection that stores unique values. So what that means is that this array that we're given, what we could do is that we can take all the values inside of array and try to push them in a set. So here I'm able to push in the 2, the 3, and this 1 right here. But when I take this one and I try to push it into the set, it will not allow it, because this one already exists in here, and because it only takes in unique values, the second one right here will not work. So the goal is to basically use a set to see hey, does this value already exist inside of the set? Well, if it does, then that means we found a duplicate number, and that means we can return true. So this has a really great time complexity of O of n, but the thing is, you'll notice that yes, the space complexity has been increased from O of 1 all the way up to O of n as well. And this is one of those situations where, yes, the space complexity will go up, but I'm willing to sacrifice that if that means I can dramatically drop the time complexity. So this is one of those situations where you kind of have to think, well, maybe what am I willing to sacrifice to get the best possible solution? And this is, in my opinion, one of the ways you should kind of go about this problem to avoid the more extreme time complexities that you could get. All right, let's go ahead and break down the logic. So the first thing I want to do is I want to create a set. I want to loop through nums array. I want to check if the current value that I'm looking at is not inside of nums. If that's the case, then I add it to the set that I'm creating. Else, I'm returning true. And when I'm done with this loop, that means I could not find any similar numbers. So that way I'm going to go ahead and just return false. So let's get started. Now you want to create a set. So I'll call it scene and do new set. So that creates a set and it makes this equal that. Now I want to do a for loop. So for let I of nums. And what this does is that this will loop through every single value inside of nums one at a time, and this letter I will represent whatever value that I'm looking at. Now I want to check to see, if the current value is not inside of it. So what you're going to do is you're going to do if exclamation point scene.has I. Now what this does, it says it looks at the set. It has, does it have the current value? Now normally that would be the case, but with this exclamation point at the end, it's basically like the opposite. Like if this is not true, is basically what it's saying, because of the exclamation point. If that's the case, then I would want to add it to the set. So I do scene.add I. So sets have built-in things you can use. So this checks to see if it exists inside of it, and this pushes it inside of it. Now, if that's not the case, if we found this value inside of here, then I just do else and return true. And now that we're done with this loop, if we get out of it, we can just return false. And that will say that all of the values are unique. So I'm going to go ahead and submit it. All right, and we passed. So that is the end of this video, and I hope you found it helpful. So one bit of advice I want to give before we wrap this video up is that I want to make sure that you actually take the time to learn the first two solutions. Now, for this question, yes, the third solution is way better than the other two, but there might come a time where you're going through LeetCode questions and those first two algorithms are going to be the only algorithms that actually make sense to solve that problem. So yeah, they're higher time complexity, but they're not useless. Like they could come in handy one day. Speaking of coming in handy, you might come in a situation where you're in an interview and the only solution you can come up with is a super brute force solution. And personally, I believe that it's better to have a super brute force solution to solve a technical interview than no solution at all. And the best part is if you have a brute force solution, a lot of times you can build off of it in an interview. So yeah, they may be higher time and space complexities, but don't write them off as useless. Learn them so that you can use them in a time where you might be desperate to actually need some type of solution. So that is the end of this video, and thank you so much for watching.